Right now, somewhere within arm's reach of you, there's a small glowing rectangle. You already know which one, and in the next hour, without deciding to, you will probably pick it up. Not because you need to, not because anything important happened. You'll just feel a small, quiet pull, and you'll follow it. Most people call this a bad habit, but the real answer is far stranger. That pull is 300,000 years old, and it has almost nothing to do with the phone in your hand. Your brain was not built for notifications. It was built for something else entirely, something that once meant the difference between eating and starving, between safety and danger. The phone didn't invent the itch. It just found the oldest button in your skull and started pressing it over and over 40, 60, 100 times a day. To understand why you can't stop checking, you have to go back. Not to the invention of the smartphone, not even to the invention of the internet. You have to go back to a savanna, a threat you couldn't see yet, and a brain chemical that was never designed to make you happy. It was designed to make you look. Picture an early human standing at the edge of a clearing. She hears a rustle in the grass. She doesn't know if it's the wind, a rabbit, or a leopard. Her heart doesn't wait for the answer. It's already speeding up. Her eyes are already scanning. This is the moment scientists became obsessed with decades later in a lab that had nothing to do with grasslands or leopards at all. In the 1990s, a neuroscientist named Wolfram Schultz ran an experiment with monkeys that would quietly explain your relationship with your phone. He wired electrodes into a monkey's brain and measured a chemical called dopamine, the same chemical people casually blame for addiction today. Schultz expected dopamine to spike when the monkey received a reward, a squirt of juice. And at first it did. But then something unexpected happened. Once the monkey learned that a particular light meant a reward was coming, the dopamine spike moved. It stopped happening when the juice arrived. It started happening the moment the light turned on, before the reward. Not because of it. This was the discovery that changed everything. Dopamine isn't the chemical of pleasure. It's the chemical of anticipation. It fires hardest in the space between wanting and getting, in the gap of not knowing yet. And here's the part that should make you a little uneasy. When Schultz made the reward unpredictable, giving the juice only some of the time after the light, the dopamine spike didn't shrink. It grew. Uncertainty didn't dull the anticipation. It sharpened it. Now think about your phone screen, dark and silent on the table. You don't know if there's a message. You don't know if someone liked what you posted or replied to what you said or shared something that will make you laugh. That not knowing is not a flaw in the design. It is the entire design. Every time you flip your phone over, you are recreating Schultz's light switch, and your brain lights up before you even see what's underneath. But dopamine alone doesn't explain why checking never quite feels like enough. For that, you need to travel from a primate lab in the 90s to a different laboratory, one built around a much older, much blunter idea about behavior. And it starts, strangely enough, with pigeons. In the 1950s, a psychologist named B.F. Skinner placed pigeons inside a box with a lever. Peck the lever, get a food pellet, simple. But Skinner didn't stop there. He started changing the rules. Some pigeons got a pellet every single time they pecked. Others got a pellet only sometimes, on no fixed pattern at all. Logic would suggest the pigeons getting food every time would peck the most, since they were being rewarded consistently. Logic was wrong. The pigeons on the unpredictable schedule pecked harder, faster, and longer. They pecked even when no food was coming for long stretches. Skinner called this variable ratio reinforcement, and it turned out to be one of the most powerful behavioral patterns ever documented. It is, not coincidentally, the exact mechanism behind every slot machine in every casino on Earth. You are not a pigeon. But your nervous system doesn't know the difference between a lever and a screen. Every pull to refresh, every scroll, every unlock is a peck at the lever. Sometimes there's a pellet, a message, a like, something funny. Sometimes there's nothing. And the nothing is what keeps you coming back, because your brain, like Skinner's pigeons, has learned that the reward is unpredictable, which makes it worth checking again and again. Right now, somewhere, a person is designing an app feature using this exact principle in a building far from any farm with no pigeons in sight and no leopards either, just the same old machinery repurposed. So the itch is ancient and the trap is engineered around it. But there's still a gap in the story. If checking your phone gives you a dopamine hit, why doesn't it ever feel satisfying? Why do you put it down and pick it up again 10 minutes later like nothing happened at all? This is where a researcher named Kent Berridge enters the story and where things get genuinely strange. Berridge, working with rats, discovered that the brain actually has two separate systems that most people lump together as one. There's wanting and there's liking. Wanting is dopamine. It's the drive, the pull, the itch to seek something out. Liking is a completely different chemical system involving opioids, and it produces the actual pleasure once you get the thing you were after. Berridge found you could crank up a rat's wanting system to the point of frantic, compulsive seeking without increasing its liking at all. The rat would work itself into exhaustion chasing a reward it barely enjoyed once it arrived. Does that sound familiar? You feel the pull to check your phone. You check it. For half a second, there's a flicker of something. And then, almost immediately, the pull returns aimed at the next thing to check. The wanting system fires constantly. The liking system barely gets a word in. This is why an hour of scrolling can leave you feeling emptier than when you started, even though technically you got exactly what you were seeking. You got the notification, you got the video, you got the reply. Wanting was satisfied. Liking never showed up to the party. Now, here's a question worth sitting with. Why would evolution build a system this cruel? Why would it hand you a drive that's louder than the reward it's chasing? The answer takes you out of the lab entirely and back into the world where this system first had to earn its keep. For nearly all of human history, information was not entertainment, it was survival equipment. Knowing where the fruit trees were ripening, knowing which neighboring group had grown hostile, knowing who in your camp had turned against you while smiling to your face. This kind of knowledge kept you fed, kept you safe, and kept you inside the group, which mattered more than almost anything else because outside the group alone you did not survive long. The anthropologist Sarah Blaffer-Hrdy has spent much of her career studying exactly how dependent early humans were on constant social monitoring. Unlike most primates, human infants required so much care that mothers relied on a wide network of others, aunts, grandmothers, older siblings, unrelated group members just to keep a single child alive. That dependency meant your ancestors couldn't afford to be socially oblivious. Missing a shift in the group's mood, an alliance quietly forming, a resource quietly disappearing, could cost you support you desperately needed. So the brain evolved a kind of background radar, always half, scanning the social environment for new information because new information was never neutral. It was almost always relevant to whether you'd eat tomorrow. The anthropologist Robin Dunbar took this idea further with his research into gossip. Dunbar argued that human language itself likely evolved not primarily to share facts about the physical world, but to do socially what other primates do by picking lice off each other's backs. Gossip, in Dunbar's framing, is grooming with words. It's how humans maintained the sprawling social bonds that made large-scale cooperation possible, far larger than any group held together by physical grooming alone. And crucially, Dunbar found that gossip wasn't some frivolous distraction from important conversation. Across recorded conversations, the vast majority of human talk, in every culture studied, was social. Who did what? Who said what? Who's in, who's out? This wasn't noise. It was the operating system. Put these two threads together, Hrdy's survival radar and Dunbar's social grooming, and something clicks into place. Your ancestors were built to crave social information the way they craved food and water, because both were forms of the same currency, staying alive inside a group that could not survive without cooperation and could not cooperate without constant social updating. You were never checking your phone for no reason. You were running the oldest software humans have, a radar built to scan for who's talking about you, who needs you, who might threaten you, and what's changed in your world since you last looked away. The problem is not the radar. The problem is what it's now pointed at, because here is the twist, the one that should genuinely unsettle you a little. That radar evolved to scan a world with limits. A tribe of maybe 50, 150 people at most, which not coincidentally is roughly the number Dunbar calculated as the upper limit of stable relationships a human brain can actually track, a figure now known as Dunbar's number. In that world, the radar could occasionally rest. There were only so many people, so much gossip, so many things that could possibly be new. Eventually, you'd caught up. The scanning could stop, and your nervous system could settle. Your phone doesn't offer that mercy. It connects your ancient scanning instinct to a social world of billions, refreshed every second, forever. There is no catching up. There is no bottom. Every scroll offers a small, real chance of new social information, an actual message, an actual event, an actual piece of gossip about people you actually know, tangled together with an endless supply of strangers' lives, strangers' opinions, strangers' outrage, all delivered through the exact same channel your brain once reserved for people who mattered to your survival. Your radar cannot tell the difference. It fires the same way for a message from someone you love as it does for a stranger's algorithmically selected argument on the other side of the planet. To a system built for a village, all of it registers as relevant. This is not a personal failing. This is what happens when a radar built for 150 people gets pointed at 8 billion, with a feedback loop engineered by people who have read the same research you just heard and built products specifically to trigger it over and over all day, every day on purpose. So what do you actually do with this? Not much if the goal is to shame yourself into willpower, because willpower was never really the mechanism at fault. The dopamine anticipation loop, the variable reward schedule, the gap between wanting and liking, the ancient radar for social relevance, none of these are character flaws. They are, every single one of them, features. They kept your ancestors alive. The tragedy is not that you have them. The tragedy is that they were never built for a world with 100 billion notifications flowing through it every day, and nobody adjusted the settings to match. Some people try turning off notifications entirely, and it helps a little because it removes some of the unpredictable light that switches on Schultz's dopamine spike before the reward even arrives. Some people try leaving the phone in another room, and it helps too, because Barrage's wanting system, powerful as it is, still needs a trigger nearby to fire. But none of this erases the radar. The radar is staying. It's older than agriculture, older than language probably, older than the modern human skull itself. The real shift isn't about silencing it. It's about recognizing it the instant it fires, that small flicker of urgency that feels like it's about something urgent, and asking gently whether it actually is. Sometimes it will be, a friend genuinely needs you. That's real, and the radar earned its keep detecting it. Most of the time, though, it's just the oldest trick in your biology dressed up in a new machine. There's a strange kind of relief in knowing this. The pull you feel isn't proof that something is wrong with you. It's proof that your ancestors survived long enough, cared about each other closely enough, and paid attention carefully enough to pass that same radar down through hundreds of thousands of years, generation after generation, until it landed fully intact inside your skull, aimed now at a screen instead of a savanna. Right now, that small glowing rectangle is still within arm's reach. You might still pick it up in the next hour, but the next time you feel that quiet, wordless pull to check it, you'll know exactly what's actually happening underneath. It's not the phone calling you. It's 300,000 years of your ancestors still scanning, still listening for the rustle in the grass, still trying in their own ancient way to keep you safe.